Hey guys, I'm going to go over your study guide for angles and triangles. I would suggest that you do the study guide first, check it with the answer key, and then come back to this video when you're ready to check any questions that you missed or didn't understand. I'm going to jump right in with the first section. The first section says I can classify angle relationships. Number one wants to know what's the relationship between angle 2 and angle 3. So if you find those angles, they make one big straight line. So if they make a straight line, they make 180 degrees in total. That means they are supplementary, and because they're right next to each other, that also means that they are adjacent. In number two, I'm also looking for angle 2 and angle 3. I see that together they make this little box. When I see that L shape, I think 90-degree angles. It's always right to give me a complement, is the little phrase that I say to remember that when two angles make a 90-degree right angle, they are complementary to each other. But because they're also side by side, they are adjacent angles. You can see they share that same vertex and that same included side. On number three, I first see two perpendicular lines and I see a right angle. So if that's a right angle there, then angle 1 is also a right angle, angle 5 is a right angle. And then the question asks me about the relationship between angle 3 and angle 4. Those two angles together are making a right angle. So just like number 2, if two angles make a right angle, we would say that those two angles are complementary to each other. And because they're side by side, they are adjacent. On number 4, angle 1 and angle 3 are like looking in the mirror at each other. If I were to measure these two angles, they would have the exact same measurement. That's because they are vertical angles. Vertical angles are congruent and vertical angles are across from each other. Number 5 looks a little bit tricky, but it's actually easier than you think. It's a straight line, and you already have one of the angles on it. One of the angles, angle 2, is worth 90 degrees. So you know that angle 1 and angle 3 need to add up to also make 90 degrees. Whenever two angles need to add up to make 90 degrees, we call them complementary because it's always right to give me a compliment. That's what I always remember. And they're not adjacent because they are not side by side. There's that 90-degree angle splitting those two angles up. Number 6 asks about the relationship between angle 2 and angle 3. When I find these two angles, I see that they fall on a straight line. When two angles make up a straight line, they add together to make 180 degrees total, which means they are supplementary and they are also adjacent because they share that same common side. So this is a question that looks just like number 1. For the next section, we're going to take what we know about classifying angle relationships and we're going to apply that to write and solve equations. So looking at number 7, I see that I have two angles that together make 90 degrees. This means that the angles are complementary. So I know that this angle, x minus 18, plus the other angle, which is x, needs to add up to 90 degrees, like we just said. Now that I have my equation set up, I can actually solve this out by drawing my line on that equals. I look on the left side and I see if I can combine any like terms. X's go with X's and I see two of them, so I have two X's, and then that is a minus 18 there. So 2x minus 18 is just the simplified version of that expression. That all is going to equal 90. Now I can start solving. I need to get my numbers on one side and my letters on the other. I want to isolate my variable. So I'm going to use inverse operations to solve. I'm going to get rid of a minus 18 with a plus 18. And if I do it to one side, I have to do it to the other side. On the left side, that cancels and I'm left with just 2x. On the right side, 90 plus 18 I can do. That makes 108. And now I'm going to do one more inverse operation so that I can fully isolate my variable. I want to get the x all the way by itself. So I see it's a 2 next to an x. That means it's being multiplied. So I'm going to divide to get rid of it. And if I do it to one side, I have to do it to the other side. So now I'm left with 1x equals 108 divided by 2, which is 54. That means that angle x, that equals 54. So that's one of the angle measures. And the other angle is worth x minus 18. If x is worth 54, then that angle is 54 minus 18. That makes 36 degrees. I would always encourage you to check to make sure that you got the right answer by looking back at your original angles. 54 plus 36 needed to make a right angle. It's supposed to add up to be 90 degrees. 54 plus 36 does make 90. So I know that I did that correctly. Let's go ahead and look at number 8. These two angles make a straight line. That means that these two angles are supplementary to each other, or they're going to add up to equal 180. So I'm going to start with the first angle, which is just x, plus the second angle needs to equal 180 degrees total because, again, they lie on a straight line. If they are on a straight line, they'll add up to be 180 degrees. Now that I've got my equation set up, I can actually solve. So I start by drawing my line down the equals, and I want to simplify anything I can on the left first. So I see an x plus 2x. I can do that operation. X plus 2x is 3x, and then I want to bring everything else down. Now that I've got both sides simplified, I want to use inverse operations to isolate my variable. Since I'm working backwards, I need to get rid of a plus 24 first. I do that by taking away 24. And if I do it to one side, I have to do it to the other side. 24 minus 24 cancels, so I'm left with 3x equals 156, because 180 minus 24 is 156. And then I see a number next to a letter. That 3x means 3 times x. So I'm thinking, what number times 3 gets me to 156? If I want to undo that, I'm going to divide by 3 to get rid of the times by 3. If I do it to one side, I have to do it to the other side. That leaves me with x equals 52. Now I'm going to plug these back in to see what those angles measure. So the first angle is just worth x, so that is 52 degrees. To find the measure of the other angle, I need to plug in that 52 into the x in that expression. So 2 times 52 makes 104, plus 24 makes 128. And then again, I would always check these by making sure that these two numbers add up to be 180, since they're on a straight line. 52 plus 128 does make 180, so I know I solved my equation correctly. I'm going to do number 9 just like I did number 8, except on number 9, I don't have a picture. It's a word problem. But I underline the important information. It says two angles are supplementary. Supplementary means they add up to be 180 degrees. And it tells me the measure of the two angles. So 4x is the first angle, plus the 2x plus 6 is going to equal 180 in total. That's what supplementary means. Now I'm going to draw my line down the equals, and then I'm going to simplify what I can on either side. So on the left, I see 4x plus 2x. I can actually do that. So I can combine those to make 6x, and then bring down everything else. And then I can start solving my equation. I'm going to do that by getting rid of the plus 6 first. And if I do it to one side, I'm going to do it to the other side. 6 minus 6 cancels. I bring everything else down. I can do 180 minus 6. That gets me 174. And then now I need to figure out what times 6 equals 174. If I'm working backwards, I'm going to think division. Since that's a times 6, I'm going to divide both sides by 6. Now I'm left with 1x equals 174 divided by 6, which is 29. Now, the only thing different about this one is that in the last examples, one of the angles has already been x. In this case, the first angle is 4x. So when a number is next to a letter, it means it's being multiplied. And we know that x is 29. So to figure out what the first angle is, we do 4 times 29. That got me 116 degrees. To figure out the second angle, again, I'm going to plug in that 29 into the x in that expression. So 2 times 29 makes 58, and then I have to add on that 6, and that's how I get 64. So I found my two angles, 116 and 64. My last step is always going to be to just double check myself. If they're supplementary, those two angles need to add up to be 180 degrees. 116 plus 64, I just punched in my calculator, and it does come out to be 180, so I know I did everything correctly. In the next section, I'm going to do the same thing as I did for the last 3, except on these 3, I'm going to use vertical and adjacent angles to write and solve equations. So on number 10, I see that these are adjacent angles because they are side by side, and they combined make a total of 54 degrees. So x plus the 37, so yellow plus blue, combine to make the green 54 in total. This is a one-step equation. So I'm going to get rid of that plus 37 from the x, and if I do it to one side, I'm going to do it to the other side. So now I'm left with what x equals. 1x equals 17. Since the angle that we're missing here is x, that means that we're already done. the angle measures 17 degrees. And then I would just check that by doing 37 plus 17. Together, those add to make 54. So I know I did my math right. So number 11, I see two angles across from each other. If two angles are across from each other, they are vertical angles. And I know that vertical angles are congruent or equal or same. So that 2x is going to equal the x plus 35. So just like any other equation, I always draw my line down the equals. And then I just want to remember that I'm trying to get my x's on one side, my numbers on the other. If I look at my equation, my x's are already on the left side. So I can actually move away that x on the right to the left. And I do that by taking it away. I can take away one x from each side. If I do that, these x's cancel, so I'm left with just 35. And on the left, 2x minus 1x, that leaves me with 1x. So 1x is 35, and I'm done. So I found what x is, but I'm not all the way done yet because I didn't figure out what the angle measures. So the first angle is 2x. That means 2 times x. So 2 times 35 makes 70 degrees. And I should check it with my other one. 35 plus 35 also makes 70 degrees. I know that both these angles are going to equal each other because they are vertical angles, and vertical angles are congruent. I'm going to look at number 12. I see two adjacent angles. They're side by side. And I know it kind of looks like they make a right angle, but they do not. It tells me out to the side here that it actually adds up to be 78 degrees. So I know that that 2x right there plus the 3x minus 6, that's the second angle, equals 78 degrees in total. Now I'm going to simplify what I have on the left side. I can do 2x plus 3x. That makes 5x. I'm going to bring everything else down. So now I can solve this two-step equation. I do that by working backwards. I'm going to get rid of that minus 6 first with a plus 6. If I do it to one side, I have to do it to the other side. So I'm left with 5x equals 84. And then I want to get rid of that times 5 with a divide by 5. And if I do it to one side, I have to do it to the other side. So 84 divided by 5 gives me my answer. X equals 16.8. Now, I'm not done yet because I need to figure out what each angle measures. I know the first angle is 2x, which means 2 times x. I know that x equals 16.8. So all I need to do to figure out what that first angle is do 2 times 16.8. And I got 33.6 degrees. For the other angle, I need to do 3 times x and then take away 6. Since I know that x equals 16.8, I'm going to start by doing 16.8 times 3, and I get 50.4. And now I need to subtract 6 to figure out what this angle is. I got 44.4 degrees. My last step is always going to be to check to make sure that I did my math right. I know that this plus this needs to equal 78. So this plus this needs to add up to equal 78. So I can just check that really quickly in my calculator. And when I do that, I do get 78. So I know that I did my math correctly. In the next section, we're going to apply what we know about triangles to answer some of these questions. For the first three, we're looking at corresponding angles and side lengths. So when I see an angle like this one on A, it says angle XYZ. I'm going to trace that angle with my green pencil. Now watch me, X, Y, Z in that order. That means that I'm looking at angle Y. So the corresponding side that matches with that is this yellow side, the one that I did not shade, because it's across from that angle. So X to Z makes that line and that side length, and since it's a segment, I'm going to just put a little line over top of it. We'll do the same thing for B. Again, when you look at the angle, you want to do it in the order that it's written. So start with Z and then go X, Y. That means that I'm looking at angle X because that's the one in the middle. So the side length across from that angle is YZ. I can write that as ZY or YZ either way, as long as you put it down and then put a little line over top of it. It's a line segment, not an angle measurement. All right, and then last one, angle YZX corresponds with the side length across from it. It's almost like a flashlight, spotting a flashlight onto this line. This line is XY. So I write XY, doesn't matter what order, as long as you put a little line on top of it. For number 14, on A, B, and C, I need to know the triangle sum theorem. The triangle sum theorem tells me that all of the interior angles of any given triangle have to add up to be 180 degrees in total. So if I have two parts of the puzzle, I can take those off of 180 to find that missing angle. So that's what I'm going to do. I'm going to take 180 and I'm going to take off 88. And then I'm also going to take off 33 because, again, those are the two angles that I already have. What I'm left with will be that missing angle, which is 59 degrees. Again, I would always double check my work. So I would do 88 plus 33 plus 59, and that should total 180 degrees. Let's look at B and do the same thing. Take 180 and then take off the two angles that you have. So take off the 79 and then take off the 29.4. What you're left with will be that missing angle, which is 71.6 degrees. And again, add that to these two angles just to double check that you've got 180. Let's look at C. Same strategy, but I can do this one even a little bit quicker in my head because I know that 40 plus 40 is 80 right there. And I know it needs to add up to be 180, which means that this angle can only be 100 degrees, which makes this an isosceles triangle. Number 15 is asking me about side lengths of a triangle. So I need to know my triangle inequality theorem. Basically, that means that any two sides have to add up to be greater than the third side. So what I would do is look at your options and start adding stuff up. So look at A. 12 plus 5 makes 17. 17 is not greater than 17. It has to be greater than that third side. So it cannot be A. And just keep doing that for each one of these. So on B, 10 plus 15 is 25. 25 is bigger than 24, so you move on to the next two. 15 plus 24 is greater than 10, and then you do the last two. 24 plus 10 is greater than 15. So right there, I know that it's B. Just to make sure I can check the other ones, 7 plus 6 is not greater than 21, so I know it can't be D. And 9 plus 11 is not greater than 22, so I know it can't be C. The two sides have to be greater than the third side. All right, for the next section, we're going to be able to solve for missing angles or sides. Then we're going to classify the triangles. So looking at 16, I see I have a 61-degree angle. I have a right angle, which is worth 90 degrees. And then I have a missing angle X, and that's what I'm going to solve for first. Because I know there's 180 degrees in any given triangle, I'm going to do 180 minus 90 minus 61, and I'm left with my missing angle, 29 degrees. Now I'm going to classify this triangle by side and by angle measure. I'm going to use my chart here to the right, starting with by side. If I have three different angle measurements, I also have three different side lengths. If it has no equal sides, that's a scalene triangle. And then by angle, if I even have one right angle, it's a right triangle. So this would be an example of a right scalene triangle. Let's look at 17. It says start by determining the missing value of X. X is an angle, and I have two of them. So I know that in total, I need 180 degrees. So I'm going to do 180 minus the two that I have. That leaves me with 54 degrees. So that's the measure of the missing angle. I'm going to start by classifying this triangle by side length. Since none of the angles are the same, that means that none of the side lengths are the same. So this is another example of a scalene triangle. And then I'm going to measure it by angle. Since all three angles are less than 90 degrees, I know that this is an acute triangle. So I'm looking at an acute scalene triangle in number 17. Let's look at number 18. You're going to notice two things on number 18. You're going to notice these two lines. The single line represents equality. So the corresponding angles for these sides are going to be equal as well. It means that those sides are the same length and their angles are going to be the same length too. So this is another 32-degree angle here. Now I'm missing one angle measurement, and I know that all the angles in this triangle have to add up to be 180 degrees. So I'm going to do 180 minus 32 and then minus the other 32, which leaves me with 116 degrees for that missing angle. When I classify this triangle by side length, I see that it has two equal sides. I always remember I saw two equal sides. I don't know, that just helps me remember it. That's going to be isosceles. When I classify by angle measurement, I see it does not have a 90-degree angle. And I'm looking at some acute angles. I see a 32 degree and a 32 degree. But then I have this 116. For it to be acute, all three angles have to be less than 90 degrees. So number 18 is an obtuse triangle because one of the angles is greater than 90 degrees. That's what makes it obtuse isosceles. All right, let's look at the last one. I see that I have two side lengths that equal 6 centimeters. So those are the same. A 6 is a 6. That means that the angles that correspond with those side lengths are also equal. So this is also worth x. So I'm thinking 90 plus 2x equals 180. And I know that's a 90 because that's a right angle there. So basically what you're thinking is, I need another 90 to make 180, and then I'm going to cut that in half because it has to be the same. The only number that works there is 45. This has to be 45-degree angles where the x's are. Now, if we classify this by side, we know that we have two equal sides, so it's isosceles. And we know that it has one right angle, which means it has to be a right triangle. So this is a right isosceles triangle. The next section is going to look different for everybody, but I just did two examples, and it's also not going to be to scale on your screen, but this is just kind of maybe what yours might look like. As long as you have on number 20 one obtuse angle, so one that's bigger than 90 degrees, and then one side length measures 4 centimeters, you should have the right triangle. On number 21, it's asking for a triangle with one 45-degree angle, and then all sides have different measures in lengths, which is a scalene triangle. Again, yours is probably going to look different than mine, but here's just two examples of triangles that meet that criteria. So for the next section, I would go ahead and have my triangle conditions paper out with me as a little cheat sheet to look at this. I'm just going to go through the answers and make sure that they make sense to you. For number 22, you're looking at card A, and you're going to decide how many triangles you can form. So what you're given on card A is side lengths of a triangle. What you're going to want to see is that if any two side lengths get added up, are they greater than the third side? If they are, then it forms a unique triangle. So you can see that's my explanation here. 6.3 plus 4.2, the first two, add up to be greater than 10.4, the third side. And the same is true if you add up 4.2 and 10.4. That's greater than 6.3, and so on. So that makes one unique triangle. For 23, you're looking at card B. Same thing as card A. You're given three side lengths of a triangle. But since 2 plus 3 equals 5, this does not form a triangle. It has to be greater than the third side length when you add up any two sides. It has to be greater. Since it's equal, this can't form a triangle at all. Their endpoints wouldn't touch. And then card C, you're given three angle measurements. So since all three of these add up to 180 degrees, this definitely forms one triangle. But since you could change around the order of what is connected to what, it can form more than one unique triangle. And then for 25, we're going to be given two sides of a triangle with lengths of 9 and 18. And your job is to figure out what could be the possible side length for the third side. So you're again looking at that triangle inequality theorem. And all these options, the x value is between those two numbers. So that's what you're looking at. So I would start with the 9. 9 plus 9 gives you 18, the third side. So you know that the number has to already be greater than 9. So you can roll out B or D because that other number has to be greater than 9. Then my strategy for figuring out the maximum length of the other side is going to be to add up these two numbers that I have. If I take 18 plus 9, I get 27. So the number for the third side length has to be less than 27. If it's greater than 27, we got a problem. It can be 23, it can be 25, but it cannot be over 27 or 27. But it can't be A here because it could be bigger than 18. That leaves me with C. 26 says which three lengths could be the lengths of the sides of a triangle. Again, you're using that triangle inequality theorem. 4 plus 8 is 12. 12 is not bigger than 13, so can't be A. 13 plus 11 is 24. That's bigger than 23. 11 plus 23 is bigger than 13. And I know that 13 plus 23 is definitely bigger than 11. So I know that B works for this. Just to try everything else out, I can roll out C because When I look at 5 plus 12, that's 17, so it can't be C. When I look at D, I'm going to do 8 plus 16. The two smallest numbers I'm going to add up, and that does not equal a number greater than 25. So I'm going to cross that out. Again, leaves me with just B for number 26. All right, that's it. So if you made it to the end of this video, congratulations. And if you need any help with your test, let me know. Good luck.